Number of good pairs. Given an array of integers nums, return the number of good pairs. A pair I comma j is called good if nums of I is equal to nums of j and I is less than j. So basically we can get a pair if a number is equal to each other inside of this array and they're not in the same place, so they're not the same index. So that makes sure that um, we can't create a pair for 1 is equal to 1 at index 0. So yeah, here we have the output's 4 because first, going through this array, we can see that we can create a pair with the one at index 0 and the one at index 3, and then we can create a pair with the one at index 0 and the one at index 4, and then we can't create any more pairs with this one, so then we move on. Oh, well, with 2, there's just no other 2's in the array. And with 3, we can create a pair with 3. So that's our third pair. And then when we get to this one, we can create a pair with this one and this one. It's our fourth pair. And there's no 1s after this. There's no 3's after that. There's nothing after that. So we're able to create 4 pairs. I don't know how people are normally solving this, but a pattern I noticed is that, okay, so if we take like a counter of like all the elements inside of the array, so for example, we count that the number 1 occurs inside of this array 3 times, the number 2 occurs once, and the number 3 occurs twice. What you'll notice is that if we count that the number 1 occurs like 3 times, right? Then 3 minus 1 and take the summation up to like whatever the number of times they appear in the array minus 1. So since the 1 appears 3 times, we would take summation up to 2. So 0 plus 1 plus 2. And so that would be the end of 1. And for 2, for example, since it's just like the number 1, take the summation up to 0, so it wouldn't add anything. And then 3, you take the summation up to 1, so just add 1. So it would be 3 plus 1 is equal to 4. Yeah. And that's how we get the answer. At least that's like a formula that I see. You can just use math to solve this. Why does that work though? Okay, well let's take a look at this. Honestly, that works because like if you think about it, if there's 3 1s in this array, then the first one is gonna have the option to pair with 2 of them. The next one is only gonna have the option to pair with 1 of them, and the final one's gonna have option to pair with 0. So if there's 3, then for the first one we'd have 2 options, that minus 1 because you can include self, and for the next one you'd have that again, like whatever it was like 2 before, now it's 1, and so on, right? You get the idea. Okay, so if we create a real quick like a hash map, so g is equal to counter of nums, what we can do, right, for I guess like key in g, what we could do is for I in range from 0 up to key of, up to g of whatever the key is, which is basically what this is doing, right? It's getting the summation from 0, going up to key this frequency of the element minus 1, because when it comes to range, the first one is inclusive, like the starting point is inclusive, and then the ending point is exclusive, so it doesn't actually go here, it goes that minus 1. So for that, we can have a sum. It's our answer that we're going to return, right? Sum is equal to like 0. And to sum, we would literally just add I. Yeah, we would just add the, like, for example, if I were to run nums through this, so it would look, so first counter would pretty much just count up how many times each element occurs. So let's see that 1 occurs 3 times. Let's go from 0 up to g of key, which basically the first one would be like, the key would be 1. And see that 1 occurs 3 times, so 0 to 3. So 0 plus 1 plus 2, because it's non-inclusive, doesn't go 3. So as you can see, right, 0 plus 1 plus 2, that follows the algorithm that I showed you here. So that would count for 3 in total, 3 pairs. And the 2 would have nothing, and 3 is 2, right? It occurs 2 times, so it would go to, this would be a 2, but it would go up to 1 because it's non-inclusive. So that would contribute 1, and in total it would contribute 4 pairs. So sum would be 4. And we could like return sum. That would just be our answer. Okay. So, the runtime complexity for this would be oven, because in the worst case, all of our numbers could be unique. So when we create a counter nums, we could just create a counter of 1 frequency for every number. And then extra space would be oven. Because again, we can just store like every single element in nums is being stored in a counter. So it's oven for the worst case of both. All right, see ya.